Hello, and welcome to NPR News Science. I'm your host, Sophie Davis, and today we have a special guest here, HIV researcher Michaela Murr. Welcome, Ms. Murr.
Thanks for having me.
For the past 12 years, Murr has been part of a team of scientists working to eradicate HIV. Antiretroviral medicines that treat those with HIV have been around since the 1980s, when the disease first became widespread. More recent are drugs used to prevent HIV, which are just emerging. In 2004, Murr was part of a team of scientists to develop a new HIV prevention drug, Truvada. Michaela, can you tell us more about Truvada?
Well, Truvada is an antiretroviral drug that interferes with the reproduction of HIV. HIV is a retrovirus, meaning that it starts out as a single strand of RNA and becomes double-stranded DNA through the process of reverse transcription. The body's cells infected with HIV then copy the retrovirus's genetic data when it reproduces.
So, what's the difference between Truvada and other HIV/AIDS drugs?
Truvada is unique because it's a drug that both prevents the spread of HIV and treats HIV in those already infected. Its results are very promising, and studies show that Truvada reduces the spread of HIV by 96 to 99% between individuals.
So can you explain how Truvada works?
Truvada consists primarily of two drugs, tenofovir and emtricitabine. To give some background, HIV begins the process of regeneration through reverse transcription, which creates double-stranded DNA from a single-stranded RNA template using reverse transcriptase and nucleotide base pairing rules.
So how do tenofovir and emtricitabine factor into that process?
Both drugs are nucleoside or nucleotide reverse transcriptase inhibitors, meaning that they replace the HIV building blocks that reverse transcriptase uses to make DNA from the HIV template. In particular, tenofovir contains a synthetic nucleotide analog. When that fake nitrogenous base is incorporated into the DNA strand, the strand ends prematurely. Anyway, emtricitabine does essentially the same thing as tenofovir. It's a nucleoside reverse transcriptase inhibitor that, when incorporated into the DNA strand, causes early chain termination, therefore inhibiting the reproduction of HIV. By decreasing the spread of HIV into new T cells, these antiretroviral drugs protect remaining healthy T cells, allowing the host to better fight new infections and diseases, and decreasing their chance of illness.
Well, thank you, Michaela. We'll be right back after a short break. We'd like to thank our sponsors, the University of Pennsylvania, Raymore and Flanagan, the Church of Scientology, Stanley Steamers Carpet Cleaners, and Condom Kingdom. Welcome back. So, continuing our interview. Michaela, tell us what Truvada means for people living with HIV or who are at a risk of contracting the virus.
We like to compare the effect of Truvada to the effect of the birth control pill in the 1960s. Given preemptively, Truvada pretty much guarantees that you won't get HIV, just like the birth control pill almost 100% guarantees you won't get pregnant. With both the birth control pill and Truvada, a small preventative measure can prevent something that could cause a huge headache later. Truvada's no silver bullet, and it's come under a lot of criticism, not just from religious organizations, but from healthcare providers as well. When birth control pills were first introduced, there's a public outcry because people thought it would encourage behaviors that people might not engage in otherwise, such as having multiple sex partners or not using condoms. And it's true that after the pill became widespread, pregnancies decreased, but other STIs, like gonorrhea, increased. There are a lot of the same concerns with Truvada, that people will think they're immune to HIV and partake in risky behaviors, which will in turn lead to the spread of other STIs.
So, who would you recommend for Truvada?
Truvada is ideal for people at a high risk of contracting or spreading HIV. Sex workers, intravenous drug users, and especially serodiscordant couples, or couples with one HIV-positive partner and one HIV-negative partner.
But how would you justify the use of Truvada if it's so expensive? Even if people get it insured, it's still going to be the public who's paying for this pill, which some would argue isn't even a necessity if people are diligent about using condoms.
Well, I see it as more of a long-term investment. Of course, $13,000 a year, the annual cost of taking a daily Truvada pill, is a lot of money. But if you look at the progression of HIV in the United States, you'll see that 50,000 new cases are still diagnosed every year. We think of HIV as going away or dying, but it's not. We just have better treatments now. If we can curb those numbers by providing Truvada to the most vulnerable people, we can greatly reduce the number of new infections.
So, aside from the cost, which some people seem willing to overlook, are there any other difficulties with Truvada?
Well, it's been slower to catch on than we expected, and we can't attribute that all to just the cost. Just like someone were hesitant to ask their healthcare providers for birth control when it first came out, some men and women are still hesitant to ask for Truvada because of the implied judgments that someone who bothered taking an HIV prevention pill was sexually promiscuous. And even though Truvada has been very effective in preventing the spread of HIV, it only works if it's taken orally every single day, and some people just aren't that diligent. So people who might not take their pill every day could wind up dangerously confident and think they're immune to HIV, which in turn could lead to decreased condom use and more HIV infections.
So what do you see for the future of Truvada?
I think it has huge potential as an agent for stopping the spread of HIV, but for a variety of reasons, it hasn't been as effective as it could be. I think the biggest obstacle right now is the distribution. Ideally, if we could distribute Truvada to patients through something like a vaccine, something that wouldn't require daily action on the part of the patients, we could see increased interest, which in turn would lead to fewer new cases of HIV among the general population. We expect the cost of Truvada to go down over time, making it accessible to more people. But what's unique about HIV is that it's always evolving, meaning that one drug that's very effective might not be effective a year from now. So we always have to develop new drugs to stay one step ahead of HIV.
Well, thank you so much for your time, Michaela.
Thank you, Sophie.
Well, this has been NPR News Science, and I hope to see you all next week. And I hope that's helpful.